I figured that it would be a good time to actually show what I meant by a more complex rig. So here is a quick rundown of the rig of our little bot. You can see here that we are going to start with an empty scene, more or less. We have our stash with just a character. This is our final character that we deliver with this project, which basically has the complex rig that you just seen, as well as some other little bits inside the packed format here, like a control shape library, as well as you can see that the base and the antennas have been split up to account for some rig logic. But we're going to work with this because that's, it is sort of a simulated small-scale production environment that we have going here. The idea is that we have our final character, and this is the stuff that we want to configure for Ragdoll, and then essentially add to our character the Ragdoll necessary bits, right? And that's a cool thing to keep in mind, is that any Ragdoll configuration that we add will not interfere with the main character, so it's still up to you whether you want to use Ragdoll later on or not. As long as the configuration is there, you do have the option. So let's go ahead and build this stuff together. As we remember, we need a skeleton, a skin, and some shapes, as well as the limits, right? So that's the sort of the necessary data. And because we are going to use normal SOPs to build or to get that data, I want to first extract the various data pieces from our packed character, because SOPs operates on just single geometry streams, not on packed character formats. So I'm going to use an unpack folder and extract the skeleton. And I'm going to use an unpack folder and extract the skin. So I'm going to go both base and antenna.shape and extract both so we can see the full skin there. And we can check here and we can see that we no longer are dealing with any packed data. This is back to KineFX sort of land that we can operate on. So first things first, let's get the shapes going and see how we can get those to behave and look nice. So I have the Ragdoll Collision Shapes SOP here. So this has been around for, I think, H20 and even before that, but H20 got a nice revamp. So there's nothing new in here for 20.5, or nothing of interest for us right now, at least. I'm just going to go ahead and plug the skeleton and the rest geometry into the proper inputs and go into the state. And straight from the bat, we see we've got something that looks pretty good. So this SOP essentially takes the skin from the rest geometry input, dices it up based on the capturing attribute, and produces some convex shapes for each of those pieces that then we can use for the Ragdoll solver. This is done in a procedural fashion, so it's very easy for us to just change the inputs and get an updated result. However, we also have the ability to control each shape individually and adjust it if we have to. And for this particular scenario, we've got a couple of things that I would like to adjust, and especially when it comes to the helmet and the torso. We see that these shapes haven't actually kept their proper concavity, and of course, this makes sense. And I would kind of want them to, because we'd get some nice sort of jiggling motion happening within those shapes from the other parts if we did. So how can we achieve that? I'm going to go ahead and attempt to do it here. I'm going to select the helmet, and I'm going to either hit G to bring out this small menu and just look here at the top to get the options. The shape is set to convex hull, so that's good. That means that our shape will be created or will be initialized from the skin. But then the algorithm that's used to generate the shape is shrink wrap. And instead of shrink wrap, I want to use convex decomposition. So let's try that. You can see how that changes, and now we're getting a bit of a more complex shape going. And that even has a slight bit of concavity. Let me transform this shape a little bit up so we can see exactly what we're dealing with. You can see the concavity there. It's not quite as accentuated as I would like, so I'm going to go ahead and select it and attempt to lower the max concavity parameter so that we get a more pronounced effect. And you can see that this has helped a bit, but now we're starting to get this weird breakage across our shape. So let me try even lower. And yeah, we can kind of see how the concavity is getting better, but the overall shape of the helmet gets worse. And I think it's a good sort of moment to understand the fact that, as with any SOP, or most SOPs, the Ragdoll Collision Shapes is basically built in such a way that it can give you, like, it can get to 95% of the way there without over cluttering the interface or making things too complicated. So the SOP seems to be struggling to properly dice up and format this helmet. And this is because in, combination of how it sort of treats the geometry, it sort of does a poly reduce and then a convex decomposition. And if that combination sort of ends up, too brittle or too high res, then things can go a bit wrong. Regardless, what's important to note here is that, I spent about 15 seconds, 20 seconds trying to get it to work. And I think at this point, it becomes quite clear to me that I can't exactly get the concavity that I want just with this SOP. So rather than worrying too much about fiddling about with parameters and spending, the next 5 minutes just doing that for a single shape, I'm going to just accept it, and I'm going to go ahead and build this shape outside of this SOP. Okay? So let's go ahead and do that. I'm going to exit the state, and I'm going to come here back into the SOP network, and we are going to do a split. So I'm going to, or a blast, both work. I'm going to get some primitives, and I'm going to select the helmet. I'm also going to get the eye and accept that. So we just split off the helmet. All right. Now what I want to do is I want to turn this into a actual collision shape or something that could work with the collision shapes. So we are going to work with the convex decomposition SOP. This is also what the node Ragdoll Collision Shapes is using internally to build it. So if I just plug that in there and run this SOP, we can see we've got a crazy dense geometry going. And it's also, again, ruined our concavity. So let me go ahead and try something a bit lower there. You can see we're getting something. I'm going to kill the materials just for a second here. I'm going to try even lower, 0.01. You can see we get a really reasonable concavity. The shape is a bit sort of still broken apart, but it's not as broken as the one in Ragdoll Collision Shapes. This is more a visualizer thing. Also, I think it's a good point to mention right now the fact that what's actually happening here with convex decomposition is this just splits up the geometry into multiple pieces, each of the pieces being concave. So, because I did say we need a convex shape for the Ragdoll solver, and now I'm saying, oh, I want some concavity in this one. So how does that work? Well, it's basically, if you want to keep some concavity in your shape, we're going to break that shape apart into multiple shapes so that each individual shape is convex, but altogether they create something concave. So this is obviously potentially a lot more expensive for the solver, but it can get us closer to the results we're after. And in this scenario, when we're running a single character in a solve, it's perfectly fine. So I'm getting a warning here. We can't find the name, so I'm going to go ahead and turn that off. And I'm also going to go ahead and turn that off because I don't have a name or a segment attribute, or I don't want any. And we can have a look around here, and let's say we're happy with the concavity. We can have a look at our count. So we see about 17,000 primitives. So that's quite dense. So one thing we can do here is we can use a poly reduce upstream. And let's say, reduce our geometry by like 25%, and then run the convex decomposition. And this should reduce our count to about 6,000. And, it looks, I would say, reasonable in terms of concavity and shape. Let's go ahead and also just drop down a normal SOP so we can actually see this geometry a bit better. There we go. That's much better. So now we've got our shape. There's a decent concavity there. We can always adjust it if we have to, but for now we are happy with it. Now, what else do we have to do to make it an actual shape? Is first we are expected to be, so this shape is expected to be packed. So if I come back here to the Ragdoll Collision Shapes and just check the output, that's sort of the best way to figure out what the output should be like. We see it's a bunch of packed geometries. They have a bone capture, a color, and a name. So I'm going to go back to my shape, and we are going to pack it. But we can do this, for example, using a merge packed. Drop down over there. And then this one can take a name. So let's just go helmet. That's not how you spell helmet. Helmet. And this will create a single packed geometry with a name on the primitives. So just something to replicate this. And now for bone capture and CD, we don't have to worry about it, because what we can do now is we can just plug this into our collision shapes input over there. And now if I come back to our Ragdoll Collision Shapes and enter the state, we are going to see that our helmet has been replaced with the helmet that we configured upstream. And luckily for us, this SOP will now take care of giving it a color and the bone capture attribute. So to keep things as simple as possible for you to configure by hand, all you really need is a packed geometry with a single name, and just plug it in there, and there you go. It works. Worth noting that the name is not arbitrary. It needs to match the name of the joint that this shape is associated to, because otherwise the SOP doesn't know how to connect the shape, or rather, to which joint to connect it to. So let's go back in here, and we can see it looks a bit better, but we still have the problem of the torso, okay? With that, it doesn't actually have the concavity. So I'm going to go ahead and just treat the torso separately as well. I'm going to just copy and paste all my nodes, but for the split, I want to split out the torso, not the helmet. We can poly reduce that as well, no problem. Convex decomposition, which creates something like this, and then just have the normal for visualizer. We can see that our concavity is much better preserved here, and we've got a reasonable sort of 2K polygons. We can poly reduce this even further if we want to and get the nice balance of things, but this will do. And this I'm just going to put it into the same merge packed, but give it the proper name, so call this torso. And now if we come back here into Ragdoll Collision Shapes, go into the state, we see we've got both the torso and the helmet from the outside. You can see both the joints that are related to those shapes have been grayed out. This is basically telling us that those shapes are coming from upstream, and there's nothing we can do to them in this SOP. They're just here for visualizing purposes. Okay, great. So we took care of that. Now, there's not much else on a first look that is wrong. We can, for example, clean things up and delete the root just so that it doesn't show up in the viewport. Not that it actually makes any difference since there's no shape associated with it. And once we're happy with the way things look, we can come up here for the last sort of troubleshooting option and just do display intersections. And we do see that we do have a couple of problems with the intersections from the hips, into the torso and the helmet. Now, this doesn't look terribly bad, though it still is a little bit of red. What this means is that our hip shape is colliding or is intersecting against our torso and helmet at rest pose. And this can create some problems with the solver because it's going to attempt to sort of push them apart. And if they start intersecting already, this might create some weird jitters or stuff like this in the solver. Now, this doesn't happen everywhere. So for example, here you can see that our hip and the knee, even though they clearly intersect, don't show up as red. This is because the intersections are only happening between joints that are not in a direct relationship. So because here the hip is the parent of the knee, their collision is treated a bit differently. Essentially, these two shapes don't actually intersect or don't collide with each other the same way that the hips will collide with the helmet. But here, because we have the COG joint in the middle, which is the parent of both the hips as well as our torso, then the hierarchy is kind of awkward. So that creates an intersection between the hips and the torso and the helmet because it's just the way that the relationships are structured in the skeleton. We can leave it like this for now and see if there's any major issues down the line and come back and try and sort of manipulate the hips a little bit to fix that. So I'm going to exit the state and proceed with getting a basic sort of limit setup going for our Ragdoll. For the limits, we are going to go ahead and drop down another SOP, which is called Confirgure Joint Limits. Put it down, plug in the skeleton, go into the state. We can see so far so good, just a skeleton. I'm going to come up here and toggle on show all handles. which will show all the configured limits, which again, empty. This is of course because we haven't actually configured any limits yet. Now, in a similar fashion, how we're using the skin for the collision shapes to create a procedural defaults for our shapes that then we can sort of build on top of. I also like to use a external input for our configure joint limits in order to initialize our limits like that, because I don't exactly want to go in and joint by joint configure the ranges using the handle, because that's a bit tedious, especially when it comes to things that are supposed to move in a natural fashion. It's really hard to gauge exactly what you want. All right. So how can we do that? How can we do that? This node has an input called motion clip, and this is essentially a set of poses that we can read from in order to initialize those limits. So we need to first create those poses, all right? And there's a few ways we can do it. The most sort of basic way, if you don't have a rig, or perhaps you just want to work in basic FK fashion, is to just use a rig pose and pose like this. And then, you could do a bone deform, grab the skin here, like this, and use the rig pose, like, I would select all the joints and key them. Then I go to second frame, for example. I would pose the knees like that, and I could select everything and key them, and so on and so forth. And this way we can at least see the result on our skin and sort of get, the proper range of motion based on the intersections between each of the shapes, etc., etc. However, if you already have a rig, then I would advise you to just work with that directly. This is because obviously the rig is, it's going to allow us a lot to interact with our character in a much easier fashion and get some really nice poses out of. So for that, I'm going to drop down a scene animate, put it here, get our stash up above, and send this, which is again the full character properly configured, straight into the scene animate. Okay, I'm going to go into the state, and you can see here our nice rig. I'm going to select the root and just hide it for now because we don't need it. And now we can work on this rig directly. So what I could do is I would select basically all the controls and key on first frame. Then I'll go to the second frame. I'm going to also, key over there. Actually, we can just sort of, step through this stuff and do a few keys. And then I go to frame 2, and I can start manipulating. After I turn on the use click and drag option, I can start manipulating, the controls and getting the poses in here. Okay, so I'm gonna do that. Okay, I can, do the look at sort of up there. And, it's up to you how you want to do this stuff. Obviously, if you have an animator on hand, that would make things a lot easier than you trying to get the range of motion to sort of properly behave. But I still think we can get something sort of that looks reasonable out of a couple of poses here. I'm just going to make, obviously, a few ones. I'm not going to do all of them on camera because I don't want you to have to sit through it all. Okay, there we go. We got a couple of poses here. I'm going to exit the scene animate. And now what we want to do is we want out of those to build our motion clip, right? So in order to fetch the animated skeleton from the animation we just did, we can drop down an apex scene invoke, put it down, connect the scene, display this one, and I am going to come here to the scene output path, and I'm going to select our rig output, and here I'm going to come down and just do base.scale, and this will give me the skeleton animated with the parameters that I've just set. Then I'm going to do a motion clip SOP and just connect that to the motion clip SOP, which will build the motion clip for us. Now, we can be a bit more granular about this and not build it for 240 frames. We can just build it for like 10 or how many keys we had. So this gives us 10 poses in the motion clip. And now if I come here and I plug the motion clip into the motion clip input over there, display the node, come here under compute limits and enable this option. So if we have a look here in the state, we see that we do have limits for all the joints, but they all seem to be not properly initialized. Make sure you turn on recompute local transforms on the motion clip so we can get the proper local transforms for our skeleton. And now we should be able to get, there we go. Now we get the proper ranges, right? So we can see we've got a couple of ranges on our joints and, you know, the helmet and all that stuff. So this was going to be good enough for this particular example. Of course, the more poses you have, the sort of closer to your final range of motion you're going to get. But again, this is probably going to be good enough right now. Something else we can do here is actually change the order. This is just a pure aesthetic thing because this already has the shapes output. So it's going to be a bit easier and make the network a little cleaner. So I'm going to kill that skeleton and plug it there. And I'm going to do something like that. Okay, and just bring this up a little bit. And then also bring this up a little bit. There we go. So now we've got the limits, and then the limits go into the shapes, and we are good to go. All right. So once we've got this data through, we are now able to pack it back up and actually give it a whirl, see how it behaves. So I'm going to do a pack folder. Put it down there. I'm going to get this character as our target folder structure because we basically, what we want to do is we want to put our data back into the character that we already have. So again, remember, we're not exactly modifying anything, we're just adding onto it, okay? So I'm going to use that character. I'm going to go ahead in the rig tree and I am going to select the little bot.char as our target. So that's our character. And I'm going to go ahead and plug in the skeleton and the shapes, okay? So this is going to be our base.scale. And for the shapes, we can name them whatever, something like Ragdoll Shapes. And let's go ahead and make sure we hide the shapes so they don't interfere with our character. Now, worth pointing out the fact that here we have base.scale, but we already had a base.scale on our character. That means that we essentially overridden the base.scale that was already there. But that is completely fine because the only modification we did to the skeleton is just adding some extra data for the limits. So we haven't messed with it in any other way. Okay? Now we're ready with our character. But as I explained before, we do need to tell Ragdoll before we can just launch our scene animate and take it away. We have to tell Ragdoll where to find the data that it needs. And if you remember from before, we've got a Apex configure character SOP. So I'm going to drop this down after the pack folder. And this is we can use to make that connection. So let me explain how this node works, because it's pretty simple. So first things first is it asks us, what's the rig that we are going to configure the Ragdoll for? So we can use the menu up here, and we see here we've got our little bot.char/base.rig. All right, so now the node is happy, we've got it all set up. Then we can come down here to Ragdoll and add a configuration. We can have multiple per rig depending on your setup, but for ours, one is more than enough. We're going to name our Ragdoll however we want it to show up into the scene and the selection set. So I'm going to call it littlebot_Ragdoll. Then it asks us what's the skeleton that the Ragdoll needs to use. So if you remember back onto the initial setup with this like Ragdoll SOP solver, it took a skeleton as an input. And I did make a note that the Apex Ragdoll solver also runs on the skeleton. So this tells the Ragdoll where does the skeleton live so it knows how to query it. And again, we can use this and do a base.scale. You can see that this was set to relative as the menu. What does this mean? It means that the base.scale path is relative to the folder defined up here. If I switch this to absolute, I can now go, littlebot.char/base.scale. This is all dependent on your structure. If you have a character format like we do, relative is the best, because that means that no matter where my character will live in the scene, then these data paths would be correct. It's basically very similar to how when we read parameters, for example, in SOPs when we copy relative reference and stuff like that. So it's the same concept. Then we're asked, where do the collision shapes live in the scene? Okay, so remember we have a collision shape input. We need to tell Ragdoll where to fetch this from. And again, we can use the dropdown. And we see here we've got our Ragdoll shapes. So I'm just going to select those. Then I'm going to skip over this for 1 second just to finish the other up and then come back to this because this is a bit more involved. The mapping property, this asks us what's the name of the mapping attribute that we've used to basically tell the Ragdoll how to write back to the controls. Remember, we touched on this a few examples ago. We haven't done this just yet, so I'm going to leave it as mapping because that's the default, and we're going to do this after this node. And then this asks us what's the name of the configuration attribute that's used for the limits. This is again the default. We haven't actually changed it, so if we come back to this node, we can see it's still the default name, so we're good to go there. So now, what's this output/base.scale? Okay, and that is actually the correct path. So picture it this way, okay? The Ragdoll skeleton, so the skeleton that we're going to use in Ragdoll is the base.scale, which is, if I come up here, is this one. Okay? All right. So this is the rest skeleton, so it knows what the topology is. However, usually when we're working with Ragdoll, we don't want just a rest position and run Ragdoll from there. We usually do want to have some kind of animation going into Ragdoll that then we can sort of turn into a simulation at a certain frame, or perhaps, you know, have it do some other stuff more complex than just fall to the ground. So if I come back here to this scene invoke that I showed you before, I told you that basically with this scene invoke, we are able to query the resulting skeleton from our rig. So that means that in this scene invoke, under the output base.scale, we get the animated skeleton as animated by our rig. All right? That is exactly the same thing we have to do in configure character. We have to tell Ragdoll where to look for the animated skeleton so that it knows where to fetch it from for the sim. And the way we've built our rig, we know that we have an output node and a base.scale key on there, a port. And that's where once we've animated our rig in all, you know, whatever we want, however we want, then the skeleton will be piped out of that rig with the transforms modified under that key. So once that's been set up, let's also go ahead and do the mapping, just so we are map character all ready to go. So again, this takes a rig path. So I'm going to say the rig is the base.rig, and a skeleton path. So I'm going to say this is a base.scale. All right. So again, giving it the proper paths to our character. And then here we have the map by name on by default and no more mappings. Now, before, the map by name was sufficient because we had a single FK rig. But if you remember, I did mention that in Apex, we can have more complex rigs like the one we have right now. And then the relationship or the connection or the mapping, if you will, between the skeleton and the rig no longer becomes easy to infer. So that means we have to explicitly set it up. So here is the state for map character. If you're familiar with map points from KineFX that's used for full body IK retargeting, it's a very similar state and a very similar process. We see we've got a couple of joints and already mapped to controls, the ones that have been basically kept their names. So the helmet, for example, is mapped to the helmet. The COG, you know, is mapped to the COG, so on and so forth. And the ones that haven't been mapped are especially the IKs, because those will not be the same name. So we have the L foot control, which just goes to the L foot. And, you know, these are just things we can do by hand. So I'm just going to click and do away, or I can just click and hold shift, and that will just add both at the same time. So we did the IK, we did the twists. I'm not going to do the hips at all. We can see that everything else has been mapped correctly by name. So I'm good to go. We're going to close that, and we're going to come down here to scene animate. I'm going to enter the scene animate state, and let's see if we are able to get the Ragdoll configured properly. So I'll switch over to Ragdoll. we see something has happened. Let me go ahead and clean up a little bit here so we can see it better. I'm gonna move this to the side. I'm gonna turn off materials because the shape looks a little weird. I am going to then get rid of the visualizer handle, and now if I run the sim, we can see that our character does not behave as expected. So it actually breaks in half at the middle. So let's investigate why that's the case. If I come back up here to where we did our shapes, enter the state, we see we've got this COG node here, joint here. Now, this was again a stylistic choice that sort of we made during the process of building this project. And the COG doesn't actually contribute to the deformation of the skeleton. The COG is only there so that we can get the transform of it very easily when we build the rig, and have the hierarchy also just be built nicely for us. Because you did see that our rig has a COG control. So let me show that to you again. So if I enable the click and drag option, you can see that we can move the COG around and it has the correct position, etc., etc. So the purpose of that joint is purely for the rig initialization. And again, this stuff, is, you can basically do whatever you want in terms of managing your data. You can keep a skeleton just for deformation and have another skeleton for rig building. You can merge the two like we did here, especially in scenarios where you're working with very basic sort of rig initialization stuff. So in our case, the only joint that's not contributing to the deformation except the root is the COG. So we just decided to keep it in there. But because it's in here as sort of part of the hierarchy, it's essentially the first, so it's the child, the direct child of the root, and then it's the parent of both the hips and the torso. And because we haven't given it a shape, then it's treated as not part of the simulation, which means that our hierarchy gets cut here. So our hips and torso get cut in the middle, and they get split up as the solver runs. Okay? So what we can do as a bit of a quick solution is we can select the COG and we can give it a shape. Let's make it a sphere. And I'm going to turn off the transform. We're just going to keep the shape over exactly where the joint is. You can see that it's kind of awkward as the shape is literally inside the torso. Now there's no intersection, if you remember what I said, because the torso is a direct child of the COG, so there's no intersections between them, but it's still a bit hacky to do this kind of thing, right, where we just have a shape within a shape just to hold things together. But once we did that, let's go ahead and test our Ragdoll again. Go back to Ragdoll here, and if I play, we can see that our character now doesn't break apart anymore. Okay, so again, this is because now there is a shape for that COG, so it is being treated as part of the sim. However, it's kind of, again, a bit of an awkward one just because it's essentially a shape within a shape. All right, but this is a very simple, I think this is the simplest way in which we can fix this stuff, because it's, it's as simple as adding a single shape within that. However, and I think this is worth touching on, we can have scenarios where our skeleton is actually a bit more complicated, perhaps even a bit messier than what we have to work with right here. And we might want to clean it up for Ragdoll, because, when working with simulation, it's a good practice to keep things as clean as possible and just work with the deformation skeleton. Like if there's no shape and the joint doesn't contribute to the deformation, ideally you wouldn't have it in there. But if you do, and you do want your Ragdoll to just be clean and without any surprises, then we can go ahead and actually do something interesting about that. Before we do it though, let me just very quickly test that the mapping works. So I'm going to select the little bot, and I'm going to do a start recording poses and just let that run. And we can see it's nice. So we got the mapping correctly. We got some nice animation out of that. So we are happy with all of our configurations, except perhaps the skeleton bit. But let me show you quickly how we could address that point as well. So let's walk up here where we've got our skeleton plucked from our character. Okay. And we can see that there's the COG right there, point number 2. Okay. And let's say we want to get rid of the COG for the Ragdoll skeleton and just feed Ragdoll our skeleton without the COG. So for that, I'm going to drop down a delete joint. I can type delete joints, put it down there. I'm going to enter the state. I'm going to select our COG joint and hit delete. And this gets rid of the COG. Now we see that our parenting has messed up a bit because the root is now parent to the other two. So let's drop down a parent joint sub, go to the state, and parent our torso to our hips. So select the hips and go to the torso, and that you go. This fixes the hierarchy. Okay. So this just gets rid of the COG and fixes the hierarchy afterwards. There are a few things we have to take into account moving forward. For the limits, we have the skeleton plugged in, so that's fine. For Ragdoll Collision Shapes, the same thing. You can see that now we no longer have any intersection and we no longer have any COG. The intersection is gone because now the hips are the direct parent of the torso, and the intersection no longer fires because of that. So everything is perfectly happy on that front, which is great. For our limits, we can come up here where we animated our character for the poses. We can see here that our scene invoke actually outputs the base.scale, which has the COG, and we build the motion clip out of that. However, for the configure joint limits, when we are running the generate limits for joints from motion clip, we are doing a name-based matching. So if we don't have the COG in there, that's still fine. We're still gonna get the proper ranges of motion for all the other joints. All right, so that's fine. However, now when we come here to pack folder, we don't exactly want to override base.scale anymore because we've kind of messed with it, right? So what we said is we want to create a different skeleton for our ragdoll that's going to be sort of the cleaner version of our normal skeleton. But the base.scale we don't want to mess with because, you know, we've built the rig and the character's been built with base.scale in mind. So that needs to stay there for the deformation and the rig, etc., etc. So let's go ahead and instead of overriding base.scale, I'm going to go add a new entry and we can call it ragdoll.scale. Okay? So if I come out here, you see that we have a base.scale. If I'm getting this to update, we have a base.scale and we also have a ragdoll.scale. All right? So we just introduced a new piece of data into our character that we plan to use for Ragdoll. So let's go ahead and do some other stuff here as well, where I'm going to come to the map character and I'm going to change base.scale to ragdoll.scale. We can check the state, but you know, this stuff should still be working properly because we haven't actually done anything except getting rid of the COG. So that's all good. For configure character, it's the same thing. I'm going to come up here or down here to where we've got our skeleton path and change this to ragdoll.scale because that's the rest skeleton that we want. And then I'm also going to come down here to the rig output, and now we actually have a problem. And what's the problem? Well, our rig will output our skeleton. So basically this right here. Will output the animated skeleton from base.scale, which does have the COG. All right. If we want for Ragdoll to use a different skeleton, then it's not enough to just say that Ragdoll scale becomes my new rest skeleton, but my animated skeleton is still base.scale because they're different, right? So now base.scale has an extra joint, so that's not good. The solver will not like that. It will be confused in figuring out exactly how to make the connection between the rest skeleton and the animated skeleton. So how can we fix this is the question. And we can do this by augmenting our rig slightly, okay, and introducing something introducing our Ragdoll.scale as an output. So actually, let me first go ahead and explain what we're trying to do, and then I'm going to do it in Apex, just touching on it briefly. So this is our animated skeleton. Okay, this is the base.scale that's been animated. What we want to do is we want to take, let me get a few nodes here so it becomes all very nice and clear. So this is going to be Ragdoll.scale. Imagine this is like what's happening inside our Apex rig. Okay, so this is our Ragdoll.scale, this is our base.scale animated. We want to be able to transfer this animation over to Ragdoll.scale. That's essentially it, right? So to do that, in SOPs, we would do something like a skeleton blend, where we would put down our Ragdoll skeleton as the first input and our base.scale as our second input, toggle world space, and just do this. And now, if I play back, we can see we've got the animation transferred over to our Ragdoll scale. This is doing a matching by name, by the way, so it's all very simple because, again, our skeleton. Basically, our Ragdoll scale is a subset of our base.scale, so this stuff is not hard at all. But now we basically need a way to do exactly this inside our rig, because when we animate with the rig, and when the Ragdoll looks at the animated output, it needs to look on the rig and find this Ragdoll.scale. So how can we do that? Let me go ahead and fetch the rig first. Unpack folder. And I'm going to go up to the rig tree and select the base.rig and click accept. Okay, so that's our rig. I'm going to drop down and edit graph, just so we can manipulate the rig. I'm going to open up the Apex network editor, and this is the rig that we've got. Okay, we don't have to worry too much about all the stuff that's going on here. What we're specifically interested in is, come down here, this is our input, so this is the base.scale rest. Okay, so we can follow this all the way to the end of the network, up to the set point transforms. So this is setting the antenna transforms, but you can see here that the geometry input is basically the one and the same. So this comes from set point transforms here, and it goes from set point transforms over here. So this is kind of our last set point transforms node, and this gives us the skeleton. This is the geometry of the full skeleton with the proper transforms. This is our animated base.scale. So what we want to do now is we want to drop down a SOP skeleton blend. So it's exactly the same stuff that we did in SOPs right before. Okay, there's nothing, it's exactly the same node if you want, it's just a verb. And what we want now is we want for our geo input 1. So this is, if we look back here, the input 1 is supposed to be a Ragdoll scale. Now there is no Ragdoll scale in here because when the rig was built, the concept of Ragdoll.scale didn't exist. So we have to add it. And in order to add it, we can just fetch or get this input and go all the way to the beginning. Let me get this node up to one side a little bit so I can actually see the inputs and scroll back out here. Grab this geo input 1, go all the way here, plug it into next. This creates a new input, and we're going to call this Ragdoll.scale. All right, so this just brings in our Ragdoll.scale. How does it know to bring it in? Because Ragdoll.scale exists under our character data path, then the moment we run the rig is, or the state is smart enough to figure out how to make these connections between Ragdoll.scale and the actual geometry that lives under that path. Next up, there are a few things here that we need to check. So one would be world space. We said we want that to be turned on. The other one would be, I think most of this stuff should be all right by default. So because it's a verb. So the world space wasn't on by default. So we can just check here. And we also need this wait stuff to be configured. But before that, we need an actual second input. So you can see here, this is a little bit strange to work with verbs like this, but I think it's useful to go over. So bear with me, please. The skeleton blend has a multi-input. So we can plug in as many inputs as we want. we plug the single one base.scale, which is this one. But if we hover over aux geo here, we can see it's a geometry array. And that's just how the multi-input is represented in a verb. So what we can do is we can drop down a geometry or an array build geometry, and plug this geometry in there. This creates a single array with just the base.scale inside it, and then we plug that into aux geo. Okay, so that takes care of that. And then last but not least is we need to set up this blends section somehow, the n blends and basically the weights. Okay, so if we come back out here, we see that we've got n blends, which is a dictionary array. So this again, if you are familiar with attrib from parms, the SOP that fetches node parameters and turns them into attributes, it's a similar concept where in order to illustrate parameters that are multi-parms as attributes, they essentially are an array of dictionaries. All right. So how can we make that happen? Is we are going to make first an array build dictionary. So this creates a dictionary array. Get this stuff a little bit more to the side. So this gives us what we want. Now we need to plug in dictionaries into this n blends, right, to actually get the data. So imagine this blends. So n blends. This is a geometry. It's a dictionary array as a verb. And each entry in the array has a dictionary with these parameters, right? So this would be called weight and then hash. This because it's a multiparm. And this is, the next weight and hash, and their order determines the order in the multiparm. So what we actually need here is we just need to have two entries in our array. We can see there's two entries here with a weight parm, the first 0, the second 1. So I'm going to do a dict build. This is one of the dictionaries. This takes a set of arguments. I'm going to do a value float. And I'm going to plug this in as our first arg. This will be called weight hash, right? So that's the key. That's a key in our dictionary with a value of 0. And this becomes the first entry in our array. And I'm going to copy this, paste it down here, and set this to 1. And this is also called weight hash. This becomes our second entry in the array. And then this result goes into n blends. Okay, so that's basically the setup. I know it's a lot more tedious to set up in like a verb like this in Apex than it is to just do it in SOPs. But the good thing is that we do have access to the verb. So it's the same functionality as the actual SOP. It's just that we need to do a bit more craft to get the data in the proper format. So now we have the output. That's what we need. Now I'm just going to take this output and I'm going to plug it into our output and call this Ragdoll.scale. There we go. That's it. Now we've got our output, which we're just skeleton blending from one to the other. So if we now get rid of the Apex network view, this is our rig. What I'm going to do is I am going to put this into our pack folder. And I'm going to call this base.rig. Make this invisible. We don't want that clutter on screen. So this overrides our rig, all right? This isn't exactly a procedural approach. We could do it via an Apex script. The actual project in the content library has an Apex script doing it, just so that it automates the process of adding a Ragdoll.scale. But for this example, I think it's a bit clearer to explain it that way. So we're just getting our rig, we're adding that Ragdoll.scale as an output, and then we're just promoting that back to our main character. And now I'm going to go back to configure character and change the output instead of base.scale to Ragdoll.scale. And now go back to scene animate, do a reset all just so we're starting with a nice clean scene. Let's create a Ragdoll character. This looks good. I'm going to come here to the solver just to get some stuff cleaned up a little bit. There we go, there we go. And now if I run the Ragdoll, we see we've got the same result that we did before we deleted the COG, except now, of course, this is actually, you know, it's nice and clean. There's no random small sphere floating within the torso. So this is all, you know, we don't expect any problems down the line. Plus, it took care of those intersections. So again, in this scenario, this is optional. However, it's a very good practice to do this. And in cases where the skeleton gets more complex, it can actually lead to, you know, just a broken sim unless you clean it up. Let's test the mapping, making sure it's all good. I'm gonna do start recording poses and I'm gonna let that play. And we see it's all nice. Okay, stop recording poses. We're all happy with our result. So now we've configured our character.